My name is Adolf Molpe, and today I'll be talking a little bit about machine learning and show you an application of a linear regression machine learning model. So what is machine learning? Machine learning is essentially training a computerized system to make actions and make predictions based on analyzing certain inputs or attributes. Essentially, we are training our computer to think for itself. There's a really good subtopic that machine learning entails, which is classification. Classification is essentially a data mining function where we train our machine learning model or our computerized system to make actions or make predictions by analyzing patterns within record data sets or inputs. Here is a classic example. We have a binary classifier model that takes in loan applicant information and looks at certain attributes such as potential credit card history, loans that have been taken out, just any financial transaction history, and use that history to look for patterns within it. Then we can go ahead and decipher whether those applicants are either potential defaulters or potential non-defaulters by training this binary classifier model iteratively. So where is classification used in today's industry? We use classification all the way in the medical industry to predict whether tumor cells are malignant or benign. We also use them within the social media industry, where we can classify certain news articles with respect to their genres just by looking at the text of each article. We can also classify whether credit card information is legitimate or fraudulent by training our machine learning models as well. Classification is used in many different industries. So similar to classification, we have machine learning models such as linear regression. Linear regression is a supervised machine learning model where we're able to train our machine learning model to make predictions based on looking at certain inputs or attributes and compare it with their expected outputs. So here's a really good example of linear regression. We can see that in this example, as the amount of rainfall increases, the number of umbrellas sold increases linearly as well. Each dot in this graph represents a data object or a data record, where we can see that as the amount of rainfall increases, the number of umbrellas sold increases. And we apply this line of best fit to help us determine our predictive model so that we can use this line of best fit on future data sets and identify a linear relationship between the inputs and the outputs. So for this presentation, I developed a student grade predictor that implements a linear regression machine learning model. Essentially, we read in a student grade record data set and split the data into a training data set, and we predict what the student's final grade is in a grade period just by looking at different attributes. So let's go to the example and look at it real quick. So in this case, we can see that we're looking at the student's first grade period, second grade period, their third grade period, the amount of time they study in a day, the number of failures they incur, and the number of absences they incur in a semester as well. So in grade period 1, we can see what the student's grade is. In grade period 2, we can see what their student's grade is. In grade period 3, which is also known as our final grade, we can see what their final grade is. Essentially, we want to predict what their final grade is with respect to looking at what their grades are in grade period 1, 2, the amount of time they study a day, the number of failures they incurred, and the number of absences that they incur as well. All of this information will be stored within the list, which I'll mention toward a little bit later. Essentially, we split our data into a training set and a data set within this code block. And here we're using our training set to train our model. Here you can see that the accuracy of my model came out to be 80.08%, which means that it makes the correct number of predictions 80.08% of the time on different test sets. Moving forward, when we apply this to our test set, we can see that it's not entirely accurate. Sometimes it makes mispredictions. We can see here that for this student, our predicted final grade was a 4.3, but the student's final grade was actually a 6. And these are the attributes that I mentioned earlier that we were looking at stored within the list. So rather than looking at these numbers, here I coded out a visual representation that shows the linear relationship as where the number, as the number of points a student scores increases within their first grade period, the expected final grade increases as well linearly. And we can see that we make the correct number of predictions 80.08% of the time. This is why linear regression is such a useful application in machine learning today. And we constantly have to train our model to improve our accuracy. So in conclusion, we can see that linear regression is a very useful algorithm to use within machine learning. And these are some of the resources that I use to help myself learn more about machine learning and linear regression. I thank you for listening to my presentation, and I hope you learned a lot.